Okay, today we are going to first go over our answers from
Everybody knows,
yesterday.
here we go. Okay, it's great now.
You can? Okay, how about my screen? Can everybody see the answer key?
Yes, we just see you.
Okay, let me fix that. Oh, do you have me pinned?
I do. Do I need to unpin you?
I think so. Mrs. Mueller, do you see the answer key?
Yes, we do.
Okay, how about
Sorry.
Miss Lassie? Do you guys see the answer key? Not Miss Lassie. What's her name again? Lewis. Miss Lewis, can you guys see the answer key?
Yes, we can.
Okay. I'm going to hide my face now. All right, because it's turning red for being embarrassed. All right. So our answers are all given right there, and you could see yesterday from the chart that we created how to tell whether the number was prime or composite. Again, prime numbers are numbers that can't be broken through division. So they only have two factors, 1 times themselves, to build them through multiplication. So if you wouldn't mind, check your work. And of course, you're not turning this in. I would like you to keep this math assignment because it is going to be handy since it's got those definitions on it at the top. And on the back, it has that 100s chart with all our composite numbers crossed off or colored in and all our prime numbers left blank. So let's look at number 20. If you didn't get number 20, did I say that was okay and not to stay up until 3 in the morning? Yeah. So on number 20, it says a marching band had 65 students. Can the band director arrange each row? Or wait, can the band director arrange the students into a rectangular array with more than one row and more than one student in each row? The answer is indeed yes. Yes, because the ones digit of the 65 number is a 5. So 65 is divisible by 5. The students can be arranged into a rectangular array with 5 rows and 13 students in each row. Or we can make 13 rows with 5 students in each row. Okay, it just depends on how much space you want to fill up from left to right, correct? So you might be thinking to yourself, and I put it at the bottom of the screen, but for some reason I can't see it. You might be thinking, Mrs. Franzen, what is an array? Okay, I'm going to go ahead and do full screen if I can on here. All right, I can. So what is an array? I'm going to show you on the next screen. Okay. And at the end of class today, what I'm going to do is leave this answer key up just in case there were people who didn't have a chance to get all of their answers checked. Okay. So here's the next screen. An array is literally a visual representation of multiplication. So when I said in the answer that we can build an array, I literally meant that I could build a model that shows how those multiplication facts can be listed. You can do 13 times 5 equals 65, or if we wanted to change it and turn it upside up so it was tall and skinny instead of short and fat, we could do 5 times 13, okay? So that's exactly the answer that I would like you to have. And that's kind of like what I'd like you guys to start seeing when you imagine multiplication, is I would like you to imagine it as groups. So a group of 5 multiplied 13 times can make a rectangular array, okay? And we'll be doing some of that later on in the school year as well. We will be building arrays on graph paper. I promise you it's going to be fun, okay? Now, Mrs. Mueller yesterday was talking about hot dogs when we were doing that lesson with her. And I'm like, oh my gosh, that's a great math question. And it would fit in great with this chapter because we're talking about factors and multiples and least common multiple, greatest common factor, and all that business. And she asked if there are 8 hot dogs in a package and there's 10 hot dog buns in a package, who is talking to who in the hot dog making company and the hot dog bun making company, right? They want us to buy lots of each, don't they? In order to make a whole bunch of money, because if you're like me, you want to have your ratios proportional so that there's 1 hot dog to every bun, right? It bugs me when my ratios aren't proportional. So thinking about that, if there's 8 hot dog buns in a package and 10 hot dog buns in, or if there's 8 hot dogs in a package and 10 hot dog buns in a package, how many of each would you need to buy to get the same number of each? Okay, I'm gonna let you guys think about that for a minute. Okay. All right, and if anybody wants to write down the answer, even if it's just on a sticky note, and turn it into Mrs. Franzen sometime today, just give it to your teacher. Even on just a scrap piece of paper. I know I've got a whole bunch of scrap paper in my basket here in my room. You can write that answer down for me, and I think I'd like to see that. Make sure you put your name on it, okay? Maybe talk about it at lunch. That would be great. I love it when kids talk about math at lunchtime. This is what we're actually talking about today, though. Today's lesson is about divisibility rules, okay? You guys don't have to take any notes on these, though, because I've literally got a piece of paper that has all the divisibility rules on it already that you will have to keep in your folder, okay? So if your teacher happens to have that given out to you already, that's great. If not, then they'll want to find the Wednesday lesson, and it's got a puppy dog at the top, and he's in his thought bubble saying divisibility tests. And the rules for divisibility are already listed there, okay? So in your head, just read those divisibility rules while I pass out my papers to my kids, okay? You can put those away if you want them to keep going. You guys are doing great, being nice and quiet while all the classes in the whole building are listening to us, all the 6th grade classes. I'm sure what Mrs. Henwick will be able to get her on. I just had one guy ask me for a scrap piece of paper. I keep my scrap pieces of paper over there in the blue box by my printer. So if you want to give me an answer for that hot dog question, you sure are welcome to just get up and go get a piece of paper. Thank you. Yep, thank you. All right, so even if you're not done, you can just use your ears while you're getting your papers all situated at your desk. 2, the divisibility rule for 2 is every number that is even is divisible by 2. 3, the sum of the digits is a number divisible by 3. So you add all the numbers together that are in the number, and if that answer is divisible by 3, the whole number will be evenly divisible by 3. 5. If a number has a 0 or a 5 in the ones place, it's going to be divisible by 5. 6. If a number is both divisible by 2 and by 3, it will also be evenly divisible by 6. And 9. If the sum of the digits of a number is divisible by 9, that whole number will be divisible by 9. 10. If a number ends in a 0 or has a 0 in the ones place, it's divisible by 10. So let's start with 2. Every number that is even is divisible by 2. We talked about that yesterday. As a matter of fact, prime and composite numbers and divisibility rules, those 2 lessons are like they're twin sister lessons. They complement one another perfectly, okay? We recognize even numbers because they are multiples of 2. In other words, if we skip count by 2, and that number is one of the numbers, and that number is one we get when we say that, it's even. So recognize even numbers because they end with 2, 4, 6, 8, or 0. So if you're counting by 2s and you run into that number is evenly divisible by 2s. Remember this yesterday? That was our first coloring assignment. 2 is not composite, it is prime. It's the only prime even number. But all the others are factors of 2. So the 2 factors that make 2 are 1 times 2. And so 1 times 2 equals 2 and 2 times 1 equals 2. When I say factors, what do I really mean? Okay, as I'm saying factors, I mean that any number times another number. So the 2 numbers you're multiplying together in a multiplication problem, we can call them, guys, factors. So 17 times 19 equals, I don't even know the answer to that question right off the top of my head, but those 2 numbers are factors that you multiply together. So that's what I mean by factors. All right, we're going to do a little tiny game, and we don't have to do much movement with this, but if you wouldn't mind, please play along. So what I have here is a question at the top. It says, if the answer is yes, put your thumbs up. And then you'll notice right here, there's an 18. Okay, oops, I got to back up one. Is 18 divisible by 2? Well, is it even? Yes, so thumbs should be up. 23, is it divisible by 2? Thumbs should be down on that one because it ends with a 3. Or there's a 3 in the ones place. That is an odd number. If you tried to divide it by 2, you'd get a remainder. Is 428 divisible by 2? Yes. Good job, you guys. How about 73? Not so much. Good. So that's how you tell if a number is evenly divisible by 2. 3 is a little more tricky, but I think you'll get good at it quickly. Even when I'm driving, like we went on a trip on Sunday, my husband and I and my daughter and her friend. And when I look at road signs, like the mile markers, I do this because I'm weird, okay? I look at the number on the mile marker and then I add the digits of the number together and I check to see if it's divisible by 3 or 6, okay? So if the sum of a number is a number divisible by 3, that means that you can divide that whole number and not get any remainders. Let me read the screen because I was just going off the cuff there. This means that if a number has more than one digit and you add all the digits together and get the sum that is divisible by 3, then the whole number is evenly divisible by 3. Here's the example. I'm about halfway down my screen. It says if the number 345 is added together, 3 plus 4 plus 5, I get 12, right? So the sum of the digits of that number is 12, and 12 is evenly divisible by 3. So the whole number, 345, will divide evenly by 3. Okay. How about 627? 6 plus 2 plus 7 is 15, right? 15 can be divided by 3 evenly. So all I did was look at the number, say I'm at mile marker 627. My quirky math brain would add those digits together quickly in my head. I promise I'm still paying attention, watching for deer and staying on my side of the road. But I literally do that. Now, do I want you guys to do that when you start driving? No, wait until you've gotten really good at driving before you start thinking about this kind of stuff while you're driving, okay? Which is a long ways into the future. Okay. All right, 627 is divisible by 3. So basically, if you were to take 627, it can be split into 3 smaller but equal groups with no leftovers. Trust me. This will be very helpful later on when we are looking at factors of big numbers. Okay? So memorizing these divisibility rules is super important because it will make things smooth as butter later on. Okay? So game again. What about 73? Thumbs up if it's divisible by 3, thumbs down if it is not divisible by 3. Well, what is 7 plus 3? 10. 10 is not divisible by 3, so I'm going to put my thumb down on that one. All right, what is 7 plus 5? Anybody? 12. Is 12 divisible by 3? Yep, so 75 is evenly divisible by 3. Does anybody happen to know what 2 factors you can multiply together to make 75 other than 1 times 75? Yes. 25 times 3. If you have 3 quarters, you have 25 cents. Very good. How about 15? Is that evenly divisible by 3? Well, what is 1 plus 5? Well, that's 6, Mrs. Frandsen. Good job. Thumbs are up on that one. Good job. What about 12? Is that evenly divisible by 3? Well, what's 1 plus 2? 3. Does 3 divide 3 evenly? Yes. Thumbs are up. Good job. All right. Now we're in the dungeon on Mario. 1 plus 4 plus 9 plus 4 equals? Is 18 evenly divisible by 3? Yep. 18 divides evenly by 3. 3 times 9 is 18, right? So that means that the big giant number, 1,494, I don't even have to use a calculator to know, because I just add those digits together and I'll know it's evenly divisible by 3. Okay, number 45. The number 45, is it evenly divisible by 3? Yep, because 4 plus 5 is 9, and 9 will divide evenly by 3. In fact, 9 times what equals 45? 5, right? 3 times what equals 45? Does anybody know that set of factors? What do you got?
I was going to say on the last one, you said 3 plus 4, 3 times 9 is 18.
I said 3 times 9 is 18. I meant 3 times 6. I'm sorry. Grayson, it would be 15. To make 45, you would multiply 3 times 15. So remember the chart when we did the 5s for our prime and composite numbers? All right. If we look at the hundreds chart and count by 5s, we see there's a pattern. The pattern is that any number that ends with a 5 is going to be evenly divisible by 5. Now, let's look at the next one. Does it end in a 5? Yes. Thumbs are up. Does it end at a 0? These are super easy, so I didn't do as many of them. One more. Evenly divisible by 5. Very good. Very good. Now, 6 is a little tougher than 5s, so we're going to go on to the 6s. If a number is both even and the sum of the digits is divisible by 3, so it has to qualify for being even and it has to qualify by being evenly divisible by 3, then it's also going to be a number that's divisible by 6. Okay? We recognize even numbers because they're multiples of 2. In other words, if we skip count by 2 and that number is one of the numbers we get to, then it's even. We also recognize that even numbers because they have, we also recognize those even numbers because they have a 0, 2, 4, 6, or 8 in their ones place. If the sum of the digits of any number is divisible by 3 and that number is even, We know it's divisible by 6 with no remainders. Bum, 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 bum. Bum, 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 bum. Have any of you guys played Super Mario Brothers?
Yeah.
I love that game. It was like my favorite game when I was your age.
Super Mario Bros. 2. I played the original. I watched the movie. We don't talk about that.
Okay, so the number 24, is it evenly divisible by 6? Your thumbs should be up. It's even, and 2 plus 4 equals 6, which is divisible by 3. Very good. What about this one? Okay, it is even, and 4 plus 2 is also 6. So it's evenly divisible by 6. Thumbs are up. 36. Can you split a 36 by 6 and get even groups? Yes. 3 plus 6 is 9, which is divisible by 3, and it's even. What is 7 plus 2? Think of that in your head. Yep, that's divisible by 3. And is 72 even? Yes, so it's also divisible by 6. Thumbs are up. How about a bigger number like 348? It's even, but what's 3 plus 4 plus 8? This one's kind of tricky. 3 plus 4 plus 8 is 15, and 15 is divisible by 3. So we have a yes on that one. Thumbs are up again. Awesome. Now we're on to the 9s. I'm going kind of quick, but remember, this is recorded, so if you're kind of a little confused, you can watch this again, right? And there's tons of information on the web about the divisibility rules. So if the sum of the digits is a number divisible by 9, then the number is divisible by 9. So we're switching now. For the divisibility rule of 9 has nothing to do with the sum of the digits being divisible by 3. They must be divisible by 9. Okay? This means that if the number has more than one digit and you add all the digits together and get a sum that is divisible by 9, then the number is evenly divisible by 9. If the number is 945 and the digits together, 9 plus 4 plus 5 make 18, then 18, our result, is divisible by 9, and 945 will be evenly divided by 9. Okay? I think we have some practice now. Is 35 evenly divisible by 9? Thumbs up if it is, thumbs down if it is not. Well, what's 3 plus 5? It's 8. Can we divide an 8 by 9 and get no remainders? No. So this thumbs down on this one. 36. 3 plus 6 is 9. So yep, 36 is divisible by 9. How about a 900? Thumbs stayed up on that one. People didn't even have to think. Good job, you guys. How about 144? What is 1 plus 4 plus 1? Very good. Thumbs are up on that one. Because when you add 1 plus 4 plus 4, you end up with the sum of 9. All right. You guys are smart. 63. If you know your times table, that one should have been automatic too. Very good. 421. 4 plus 2 plus 1 is not so much. Thumbs should be down. 4 plus 2 plus 1 is 7, I think. Okay, the next thing we're going to do is we're going to watch a short video, okay? I'm going to send the link to this video to the rest of the teachers for them to show their kids because I forgot to set up my iPad and join the class on there to be able to make the video clear enough for everybody else, okay? This video, I'm going to tell you, is a little cringy. So you might want to, I don't know, not cringe when you watch it. Or maybe when you're done, since I love data, when you're done watching the video with your teachers, maybe you could rate it on a scale of 1 to 10 on its cringiness and let me know the results of the data. My guess it's going to be very high on the cringy level. Okay, so what we're going to do next, ladies and gentlemen, just to kind of spice it up a bit, is to pull those papers out that I handed out earlier. Okay, so do you have those handy? Let's look at them. On the one side with the puppy dog, there are the divisibility rules. Below that, it says skills examples. Number 1, 48 is divisible by 3 because 4.
You can give those to any of us, correct? Just your class has those papers?
I gave everybody papers last Friday. I meant Thursday, Friday.
Okay. All right, I don't have the ones with the divisibility rules that you had up on the board.
Oh, so that one at the very beginning of my slideshow isn't what it looks like. This one has a little doggy on it, like yesterday's paper.
Okay.
Instead of a cat, it has a dog. Oh, I guess there is a cat where it says practice makes perfect. Shoot. How do I go ahead and show them my camera again? Maybe I go like this. Embedded webcam. Hi, there I am again. So this is what it kind of looks like. And it's got the divisibility rules there. So I'm just going to hold this up while I read through it. So this example, are you able to see my small screen in the lower corner?
Yes.
All right. I'm going to read through those examples real quick with everybody, and then we'll talk about what to do. All right. 48 is divisible by 3 because 4 plus 8 is 12, and 12 is evenly divisible by 3. Then there's a little triangle. It says, so 3 is a factor of 48. I love the way they said that. So number 2, 243 is divisible by 9 because 2 plus 4 plus 3 equals 9, which is divisible by 9. And then below that it says, so 9 is a factor of 243. And then it says application example, kind of like our hot dog question from yesterday. There are 127 chairs in the lunchroom. Can you arrange the chairs into 5 equal rows? Okay, well, let's look at that one digit for the divisibility rule of 5, right? It has to be a 0 or a 5, and it's a 7. So that would have been a thumbs down, wouldn't it have? No, you can't arrange the chairs into 5 equal rows. However, if you throw 2 of those chairs out the window, you sure could, couldn't you? You'd have only 125 then. But I'm pretty sure Principal Johnson would fire me if I let you throw chairs out the window. So let's not do that. Okay. Below that, it says to practice to make perfect, right? I would like you guys to do your very best to answer those questions today. And tomorrow, remember, I don't want you to stay up till 3 to try to do this homework. Do your very best. If you have questions, feel free to reach out because you can reach out to your teacher if you want to. But I really want you to try to do what I call productive struggle. Okay? Give me just a minute to describe what I mean by productive struggle. It's a big buzzword in math. I just finished my master's in teaching mathematics. And what productive struggle means, it means you learn best when you encounter something that's hard and let your brain struggle and work through it, okay? So a lot of times if I am asked a question as a math teacher, I will answer that question with another question. Not because I'm mean, but because I want you to kind of link things together and make connections in your brain. And that's what we call productive struggle. Okay, so math isn't supposed to be scary or hard, but it is supposed to build connections inside your brain by having a little bit of struggle here and there, okay? So just know that even though you might not have the exact answer, that tomorrow you'll know the answer and I'll explain, just like I did with the number 20 on yesterday's assignment. Brody. Oh, I'm sitting at least 6 feet away from everybody. I'll be okay. Okay, thanks for reminding me about my mask. I should have a screen on, I guess. Okay, So those are due by tomorrow, the front side of this paper. Then turn it over. Whole bunch of division problems, right? Could we look at those questions and decide whether or not which ones will have remainders? Well, let's look at number 1. It says 361 divided by 4. Do we have a divisibility rule for 4 right now? Shh, don't tell anyone, but if you look up online, there is a divisibility rule for 4. I just don't teach that one. But if you want to know it, you can search it out. All right, number 2, is there going to be a remainder? The question says 303 divided by 5. Will there be a remainder? Because 303 doesn't end with a 0 or a 5, there will be a remainder on that one. Number 3, do we have a divisibility rule for 8s? No. I wonder if there's a divisibility rule online somewhere for 8s. Those of us who have lots of love for mathematics might want to check. You might want to Google that at home as homework. Okay, number 4. Is there a divisibility rule for that question? 642 divided by 6. Yeah, we have a divisibility rule for 6. Let's look at that a little closer then. Let's decide, is this one going to have a remainder, yes or no? What is 6 plus 4 plus 2? Everybody? 12. 12 is evenly divisible by 3, and it's an even number. So that number will not have a remainder, will it? That answer will have no remainder. Okay, do you see what I'm doing there? Okay, so the ones you can figure out ahead of time whether or not they'd have remainders, go ahead and do that. The ones you can't, then just solve the problem, and if you get a remainder, you do. So as you do these problems, you're going to be decoding a clue. It's a Daffy definition decoder, okay? So the rules are you decode these 2 definitions by doing all the problems, find your answer in the appropriate column, and notice that there's a letter next to it. Each time the exercise number appears in the code, write that letter above it. So there's 7, and there's 7, and they're both in the top and the bottom. So for question number 7, the letter that goes with the answer will be in 2 spots on your answer key. Okay? All right. Mrs. Franzen gives a lot of homework, doesn't she? But you have study hall today, and you have this evening. You can bring it home in your take-home side of your folder if you don't finish it in study hall. Okay, so again, I will show you the answers tomorrow as well. And if you're struggling remembering the steps for long division, just talk to your teacher. There is a great Math Antics video about how to do long division. So if maybe you show my cringy video and they need to see the Math Antics video to remind them how to do long division with remainders, maybe you could show that to them too. Feel free to do it during study hall or at the end of this math class, however you want to do that. So is there any questions from the rest of the classes throughout the building?
Meal order is good.
Yeah, I'm still recording.
We're good as well. Where are you putting this video link?
I'm going to email it to you once I get back to my desk. Okay? It'll be 2 links. One is the cringy video and the other one's the Math Antics video about how to do long division.
Okay, we're good in my class too.
All right, well, we see you at this time at this place tomorrow. You guys did so great while I was recording. Thank you so much for being respectful and quiet.